Hello everyone, myself am Shruti, working as an assistant professor in the Department of Pharmaceutical Analysis and Chemistry at Sri Shanmugha College of Pharmacy. In this video, we will understand what phenols are, why they show acidic in nature, and the factors affecting their acidity. Now let us understand the acidity of phenols. So phenols are acidic than alcohols. So phenols are more acidic than alcohols but less acidic than carboxylic acids. So this is because the phenol can lose an hydrogen ion and form an phenoxide ion. So next, phenol is considered as an weak acid. So when phenol reacts with water, it forms an phenoxide ion and the hydronium ion. So when phenol reacts with water, it forms a phenoxide ion and hydronium ion. So this is an important reason for its acidity, its resonance stabilization. So the negative charge on the phenoxide ion is delocalized over the benzene. So delocalized over the benzene through a resonance. So this delocalization makes the phenoxide ion more stable, and hence it will increases the acidity of the phenol. So once again I repeat, the negative charge on the phenoxide ion is delocalized over the benzene ring through the resonance. This delocalization makes the phenoxide ion more stable and hence it increases the acidity of the phenol. Now let us compare phenols with alcohol in terms of acidity. So when phenols are more acidic than alcohol, because of the presence of phenoxide ion is formed, and it is highly stable due to the resonance in aromatic ring. So this negative charge is spread over the ring and with increases its stability. In contrast, the alcohols form alkoxide ions where the negative charge remains only in the oxygen atom. So negative charge only remains in the oxygen atom and making them less stable. So therefore the phenoxide ion is more stable than the alkoxide ion, and this is why phenols are more acidic than alcohol. So now let us look at the acidic characteristics of phenol. So acidic characteristics of phenol. So in this slide, first the pH of a dilute phenol solution ranges between 5 to 6. So this shows that the phenol is a weak acid. And second point, when phenol reacts with the sodium hydroxide solution, which is a base, to form a colorless solution containing a sodium phenoxide and water. So containing a sodium phenoxide and water. So this reaction confirms that the acidic nature of the phenol, as it can donate a hydrogen ion and forms a salt. So this property clearly indicates that the phenol exhibits a weak acidic behavior. So once again I repeat, so first point is the pH dilute solution of phenol in water ranges between 5 to 6. So which shows the phenol is a weak acid. And second point, so when phenol reacts with a sodium hydroxide solution, so which can act as a base and to form a colorless solution of sodium phenoxide and water. So this reaction confirms that the nature of phenol, as it can donate an hydrogen ion and forms as a salt. So this property can clearly indicate that the phenol exhibit a weak acidic behavior. So now let us see the another important property of phenol. So due to this weak acidic nature, so when phenol reacts only partially with the sodium carbonate, so reacts with sodium carbonate to form a sodium phenoxide and sodium bicarbonate compound. So however, when phenol is strong enough to react with the sodium bicarbonate to produce the carbon dioxide and water. So this shows that phenol is less acidic compared to carboxylic acid. So this shows that phenol is less acidic when compared with carboxylic acid. So which can easily reacts with sodium carbonate. So which can easily reacts with sodium carbonate. So this behavior further confirms that the phenol is a weak acid. Like other acids, when phenol reacts with metallic sodium or potassium to produce a hydrogen gas. So when phenol reacts with metallic compound, maybe an sodium or potassium, to produce an hydrogen gas. However, since phenol is a weak acid, this reaction occurs in slowly. So in this reaction, two molecules of phenol, it reacts with two atoms of sodium metal to form a sodium phenoxide, and is formed along with the release of hydrogen gas. So it's formed along with the release of hydrogen gas. So this reaction demonstrates that the acidic nature of phenol, is tough, weaker compared to mineral acids. So now let us look at the effects of substituents on acidity. So first point, this resonance structures of the phenoxide ion shows that the negative charge is delocalized over the benzene ring. So negative charge is delocalized over the benzene ring, mainly at the ortho or para position. So mainly at the ortho and para positions. So this delocalization increases the stability of the phenoxide ion. So this delocalization increases the stability of the phenoxide ion. So substituents, especially at the ortho and para position relative to the hydroxyl group. So hydroxyl group, which is OH group, can significantly influence the acidity of the phenol. So it can significantly influence the acidity of the phenol. So this effect occurs through the resonance and inductive effects. So electron withdrawing groups such as nitro and carboxyl group increases the stability of the phenoxide ion. So as a result, they enhance the acidity of the phenol. So now let us compare the effect of electron releasing and electron withdrawing substituents on the acidity of phenol. So in first column, we have an electron releasing groups as methyl, methoxy and amino groups. So these groups can denote electron density to the benzene ring, which stabilize the phenoxide ion. So as a result, the acidity decreases and the pKa values increases slightly compared to the phenol. So for example, when phenol has a pKa of around 10, while substituent compounds like methyl phenol and aminophenol show slightly higher pKa values. So now looking at the electron withdrawing substituents such as nitro, chloro and bromo groups. So these groups withdraw electron density and stabilize the phenoxide ion. So this increases the acidity of the phenol and lowers the pKa values. So for instance, the nitrophenol shows significantly lower pKa values and indicating the higher, stronger acidity. So overall, electron withdrawing groups increases the acidity while electron donating groups decreases the acidity. So hence the substituents increases the acidity of the phenols when compared they are present at the ortho and para positions relative to the hydroxyl groups. So for example, the nitro group shows much stronger effect at the para position when compared to the meta position. So in this fact, it's more than 10 times stronger at the para then meta position. So when multiple nitro groups are present, their effect becomes more additive. So for instance, 2, 4, trinitrophenol also act as a also known as a picric acid, and it is a very strong acid. On other hand, the electron donating groups such as methyl, hydroxyl and amino groups decreases the acidity of the phenols. So they do by this reducing the formation and stability of the phenoxide ion. So most of the phenols are not soluble in aqueous sodium bicarbonate solution. However, the carboxylic acid are more soluble in sodium bicarbonate. Therefore, the sodium bicarbonate can be used to distinguish and separate phenols from the carboxylic acid. So when a carboxylic acid reacts with sodium bicarbonate, it forms a double salt, so which is soluble salt. On the other hand, the phenol does not react significantly, so it remains insoluble. So however, the phenols with a strong electron withdrawing groups such as nitro groups, it shows increased the acidity level. So because of this, they react with sodium bicarbonate and become more soluble. So thus this method helps in identifying and separating the different types of acidic compounds. So in this slide, we can see the effect of substituents on the acidity of phenols. So when electron releasing groups such as methyl group are present at the ortho or para position to the hydroxyl group, so this is called as methyl group. So when methyl groups are present at the ortho or para position, the hydroxyl OH group, the basicity increases and the acidity decreases. This is an example of ortho methyl phenol. So next point, when phenol itself shows a moderate level of an acidity and it lies in the middle position. So on the other hand, when an electron withdrawing groups like nitro group, so when an electron withdrawing group like nitro groups are present at the ortho or para position, they increases the acidity of phenol by stabilizing the phenoxide ion. So and good example is orthonitrophenol, so which is more acidic than the phenol. So therefore the electron releasing group decreases acidity while the electron withdrawing group increases the acidity of the phenol. So thank you so much for watching this video.